Hello, everyone. This is Elisa Baum. I am GridGain Systems Director of Product Marketing. I'll begin in just a moment, but first I'd like to conduct just a little bit of housekeeping. If you can hear me, please raise your hand using the hand icon in the GoToWebinar control panel. Let me see. Do I see hands? I see hands. You guys are great. Next, during this discussion, you will be on mute, but should you have any questions at all for Dennis, please go ahead and enter them in the questions field in the GoToWebinar control panel. At the end of the discussion, Dennis will take as many questions as possible, and those that aren't addressed will be answered in a follow-up blog post on the GridGain Systems blog. With that said, I also want to let you know that I will send you a link to both the recording and the presentation slides within 24 hours. So don't worry, you'll get those. And with that said, I'd like to thank you for attending today's webinar being presented by Dennis Magda. He's GridGain Systems Product Manager, and the topic is Apache Ignite, real-time processing of IoT-generated data. And with that said, I'll turn the floor over to Dennis. Go ahead, Dennis.
Hello, everyone. Thanks, Elisa, for the introduction. And folks, today we are going to discover and analyze one of the use cases, how you can use not only Apache Ignite for the IoT-based solution, but the whole Apache Software Foundations software stack. So in this webinar, we are going to see, let me switch to the next slide. In this webinar, we are going to actually learn what are the present demands to the software that has to be a backbone of our IoT solution. And in particular, we are going to make a breakdown of the software stack on the following components. First of all, there should be some operating system or real-time operating system that powers up our edge devices, like smartphones, smart meters, smart watches, bands, and vehicles, and so on and so forth. Right after that, that operating system has to be connected, or has to be able to connect to the outside world, so that there is a way to send out all the metrics, all the samples, all the measurements to your platform. And actually, devices should be connected to a component that is responsible for the data collection and data transformation or enrichment. Finally, once your data is kind of collected and ready to be stored in some storage, we need to decide what kind of storage you want to use. And actually, in the modern world, we think that the volumes of the data that are generated by the edge devices and all these things from the Internet of Things are so big that it's not that possible, to fit all the data in conventional relational databases. And it would be much more preferable if we use some HTAP storage, HTAP platform, which stands for Hybrid Transactional and Analytical Platform, as our main computational and storage system. And once we settle on with our HTAP platform, we also want to make sure that that platform is sophisticated enough, meaning that it has enough APIs that are needed to cover all the imaginable and realistic IoT use cases. And as usually, I will, after we will go through all this theoretical part, reviewing the IoT software stack for our use cases, I will finish my presentation, my webinar with a demo that would demonstrate how you can connect to your HTAP platform, which is going to be Apache Ignite, and how you can stream the data to Apache Ignite using Spark streaming capabilities. So let's move on. And let's start with the overview of IoT demands to the software. So actually, the first two requirements, they can resemble the requirements of the actual modern world. So most of the operations, most of the updates that are coming, that are generated, has to be, preferably, have to be processed and ingested in real time. And it's much critical to support this. Sometimes it's even more critical to support this, to provide these guarantees for the IoT real, because your solution, can measure like your solution can power up some vehicles that are driving on the streets, and depending on how quick you can receive and process different information coming from the vehicles, can result on the safety of a driver. Having this said, time series support is also one of the must for the IoT services and applications. Under the time series, we mean an ability to store the data time series. So a range of different samples and measurements that are marked, that are pointed to some point in time. And then on storing the data in such format, we have to provide an API that can execute a variety of different time-based functions, operations, and so on and so forth. For instance, it will be more beneficial to have a system that can query on time series or geographical data using SQL language. And here is why we put this requirement to this list. So we mentioned here flexible querying APIs like SQL, like full text search and geospatial support. Because as for the geospatial support, for instance, you might want to transfer, geolocation of your devices or of your vehicles, of your wristbands, and so on and so forth to your platform for the further analysis. And the platform that would store the data has to provide some APIs that can work with geospatial information. Then, depending on your IoT use case, you might be need to have some advanced APIs that can give you capabilities to do some advanced analytics, like execute business BI or machine learning routines. For instance, if you're preparing, you're developing some application or IT solution that needs to somehow use different machine learning algorithms like regressions, clustering, decision trees, or even more advanced, then it would be good to find such a platform that supports that API as well. And finally, but it's not the lowest priority for us, the platform. As I mentioned earlier, the volume of the data generated is so impressive and so big that it makes sense to have a platform that can scale horizontally, and the platform which is always highly available. And if you need to scale it out, you can do it just pretty easy. Okay, here are the demands. And now let's take a look at possible software stack that you need to keep in mind if you get down to work starting implementing your own IoT-based software. First of all, you're going to interact with the real world, like you're going to deploy smart meters in the field or in factories, or probably you're doing some software for wearables, or you're writing software for vehicles like cars or motorcycles, whatever else. And here is you need to decide what you're going to use the operating system that will work on all these edge devices. So we call them edge devices because actually they're the very beginning, and they actually provide you all the information around the environment they are deployed in, or in the environment where they're being moved. And as for the operating system, there are different choices. If you are using a kind of pretty powerful hardware that can deploy Linux, then kind of you could resolve many technical issues that might arise throughout the development. But if you're going to deploy, let's say, your software on MCUs, which are microcontrollers that doesn't have a lot of resources, and the microcontrollers that are powered by Cortex microprocessors and have, let's say, only around 1 megabyte of RAM and probably 2 megabyte of flash, then you need to, then Linux is for sure not the case for you, and you have to find out some other operating systems. And for such constrained devices like microcontrollers that have only around, let's say, that have that have RAM measured in kilobytes and flash measured in megabytes, you have to find some real-time operating system. Next, once you deployed your operating system on your devices, you need to transfer all the information from the devices or from your things, from the Internet of Things to your storage, to your computational storage, which is HTAP platform. And actually, this transfer can go via so-called data collection and enrichment layer, where you might want to deploy special software that will collect all the data from your devices, analyze it, do initial analysis of the data, transform the data, enrich the data, and after that data transformed and enriched, it will be sent to your HTAP platform for the further processing. And once the data ends up in your HTAP platform, you are ready to, we need to make sure that the platform is sophisticated enough in terms that it provides a variety of APIs that are needed and essential for the IoT software stack. And having this in mind, now today we are going to talk about Apache Ignite, and we are going to talk about another products and projects that belong to Apache Software Foundation. And this is why I'm going to cover only those products. So, and let me just give you an overview on how you can build this IoT software stack, relying only on the software developed by the contributors and committers of Apache Software Foundation. So as starting from the bottom, as an real-time operating system for your edge devices, for your constrained edge devices, you can consider Apache Minute, which is one of the newest projects that joined the big family of Apache Software Foundation. And I will give a brief overview of this product in a minute. Next, Apache Minute is going to be deployed on your hardware, and is going to transfer all the data to the next layer, which we name data collection and enrichment layer. On that layer, it's up to you. You're going to, here is we just need to have some, preferably some streaming technology that is able to retrieve or collect enormous amount of data coming from from your devices. And that technology has to be able to transform and enrich this data, preferably using multiple machines rather than a single hardware. And there are many options you can use, like Flink, you can use Spark, Kafka, or you can combine all of them. And today we are going to review and to show how to use Apache Spark for the data collection and enrichment purposes. Finally, once the data is collected and enriched and transformed, we suggest to store it in Apache Ignite. So Apache Ignite, right, we know that it's a memory data fabric with a variety of capabilities, computational and storage capabilities. And we are going to store the data in our distributed Apache Ignite cluster. And after that, we are going to use all the APIs that are available as a part of Apache Ignite for our IoT software, because Apache Ignite honestly have everything that is needed for your IoT-based applications. For instance, it fully supports distributed. It has distributed SQL engine. It supports distributed transactions. Even more recently, Apache Ignite community released a beta version of machine learning library. So there are a lot of capabilities and a lot of storage formats and so on and so forth that are needed and supported for IoT software stack. And finally, also Apache Ignite is integrated. If you take a look at the last layer, which is called application APIs, Apache Ignite is integrated with Spark. So with Apache Ignite supports so-called Spark shared RDDs, meaning that you can still keep using Spark or once your data is streamed to Apache Ignite using that API. And today I will show exactly how you can use it in your application. Okay, now let's take a look and let's briefly review every layer and give a bit more details for every proposed technology. As for the device operating system or real-time operating system, so Apache Manute. So actually, this is a platform that was developed for constrained devices that are powered by Cortex M1, Cortex M1, 4, 2, 3 family, and also it can be supported, can be launched on the microcontrollers running under the CPUs, MIPS and RISC-V CPUs. As for the, this application provides all the native APIs that are needed for you, to access a variety of different peripherals available, like GPIO pins, different hardware buses like I2C or SPI, everything that is needed, for you to create something usable from your hardware. And for sure, you can also, store your data on special flash operating system. And once you created your device that is powered by Apache Manute, there are different ways how you can transfer the information from your devices. Presently, the operating system supports a Bluetooth low energy protocol. So this is one of the most promising technologies that is used in the IoT realm. But in any case, there is a way to to connect to your data collection layer to your platform from your devices using Wi-Fi. And as for the networking protocols, the operating system presently supports TCP/IP as well as UDP. Also, it's pretty essential for every real-time operating system to provide a management tool, package management, build management, and upgrade tool that can be used, to install the software on the devices easily without, necessity for your engineer to go to a factory, to a field, and so on and so forth. And what's exciting about Apache Manute, it keeps up with all the most popular real-time operating systems that are available in the market, and it provides its own remote firmware upgrade system. So, which means that if you, let's say, discovered some bug in your code, or you just need to upgrade Apache Minute on your hardware to the next version, you don't need to bring all the devices to your office. You can do this remotely in secured and safe way. Next, let's talk a bit about the data collection and enrichment. As I said, actually, here you can use there is a variety of different technologies that can be used for that for this purpose. But today we are just going to review one of them, which is honestly probably one of the best that exists in the market, and we are going to talk about the Spark Streaming. So Spark Streaming is an additional streaming API that is built on top of core Spark technology. And basically what it allows you to do is to retrieve data from various sources. It can be, you can get data from raw socket connections. For instance, your devices that are powered by Apache Minute can connect to your Spark machines using, I don't know, Bluetooth or other physical technology, and they connect to these Spark machines using TCP/IP and transfer all the information that measures environment conditions. And after that, Spark Streaming will get all this data from, let's say, from your devices. It will aggregate it, it will collect it, it will transform it, enrich, and after that, after Spark Streaming component does all the initial work, it will inject the data into the Apache Ignite cluster for the storage and further processing. Okay, and now let's take a look at the next component, which is our hybrid transactional analytical platform, which is Apache Ignite. And here is just, let me give you some explanation why in general Apache Ignite can be considered as a computational platform and distributed storage for the IoT scenarios. At least I have one of the use cases in mind. Many of us know company Silver Spring, which specializes in the IoT products and delivers comprehensive IoT products and platforms. And for one of the projects, Silver Spring Networks, they use Apache Ignite. And actually, what this product does is that Silver Spring deployed more than 50 million meters in different locations, and they gather information coming from these meters. This information is being transferred and stored in Apache Ignite distributed cluster, and then using a variety of different APIs that are supported by Apache Ignite, like AC99, SQL Engine, or distributed transactions. Silver Spring Networks can decide on how to dispatch and deliver power to different locations. For instance, if according to the current state of the art, Silver Spring Networks platform sees that some of the area is overloaded, meaning that there is no need to dispatch a lot of the kind of power to that region, then that power will be transmitted and rerouted to another region that doesn't have, a lot of power resources at the moment. Okay, and having this in mind, let's take a look at the main components of Apache Ignite that are needed, that are essential and that are needed to have to build a platform like Silver Spring did. So actually, Apache Ignite, as most of us know, is presently in-memory data fabric, and you can slide it in between your applications and your persistent storage. Once you do this, you can leverage from a variety of APIs like distributed SQL Grid, distributed key value operations available as a part of a data grid. Plus, if you need to write some distributed MapReduce computations, there is a way to achieve this with Apache Ignite, and much more capabilities that are not listed on this slide. But talking about the foundation of Apache Ignite, once we get the data from the devices that are running under the Apache minute supervision, once this data is collected and processed by Spark streaming framework, we need to store it in Apache Ignite. And actually, the data is stored in so-called distributed in-memory data grid. At the implementation level, in-memory data grid is a key value storage, which can scale out, which scales horizontally, and which is fully that supports which is highly available and fault tolerant. Also, if you take a look at this picture, you can see that the cluster consists of many machines. The data, every machine store a subset of the data, and when this happens, what it gives to you as an application developer is that you can load balance your workloads, meaning that all the machines you have in your cluster will equally participate in your application logic processing. And as for the most interesting APIs that are supported by data grids, we have distributed ACID transactions, and we have basic key value operations that can be used in the scenarios when you want to get or update individual keys stored in your cluster. However, if you want to get if you want to enable high availability, if you want Apache Ignite to provide you with all these high availability guarantees, you need to make sure that your cluster stores additional replica of your data. We call it kind of data backups that are stored in memory. And you can leverage from two cache modes that are available. The first one is partitioned cache, that is shown to the left. And here is, as you see, that for every key that you have in your cluster, there will be a primary node. Like if you take a look here, you will see that JVM1 is primary for key A. And at the same time, we configured our cluster in such a manner that there will be a copy of this key in one of the other nodes of our cluster. And JVM2 is the lucky guy. So this JVM2 stores kind of a copy of this key. And this is needed, just for the scenarios if this node JVM1 goes down, but your applications will not be affected because there will be JVM2 that has a copy of key A, and all the queries that are related to key A value will be directed to JVM2. And this is how it works. And once this happens, to meet your backup configuration, the cluster will elect another node that is still up and running and will back up key A on another node, on some other node. This is how partition cache works. And as for the replicated cache, in the replicated cache, there is always will be a primary node, a node that stores a primary copy of a key. Like here as we see that JVM1 is also a primary for key A, but the rest of the nodes will store the same copy of the key. And replicated caches are good for the scenarios when you just need to store reference data like currency exchange rates, and if the data is not updated frequently. So you can consider to use replicated caches. But for the most of the scenarios, partition caches are the workhorse of distributed systems like Apache Ignite. Well, that was kind of the data grid. This is how Apache Ignite stores the data. And to help Apache Spark to to stream the data into the Ignite, we have special API, special streaming API that is a part of the product, that is a part of Apache Ignite. The first thing to mention here is Ignite Data Streamer in the basic component that is shown on the left. So when you need to stream the data into one of your caches, to all your nodes, you just need to create an instance in your application, an instance of Ignite Data Streamer in your application, and feed all the data, push all the data into it. And the streamer will make sure to transfer, to deliver all this data in the fastest way to all the nodes you have. Next, you can, for every data streamer, you can set up so-called stream receiver component, which is your custom logic, which is your custom callback. That will be called on a remote node side that will receive and process the data that is being streamed from your data streamer. So if we take a look at this picture, let's imagine that Ignite Data Streamer sends out the data to this node. And also we set up a special stream receiver. And then that streamer, once the data arrives to this node, the stream receiver will be called for every entry that is delivered to this node. And this might be needed for you if you want to do additional calculations, modifications on transformations before the data will be finally stored in your cache. And as for the and also there are different ways. So Ignite Data Streamer is kind of the low-level API, so but it's kind of pretty easy to use it. And at the same time, Apache Ignite developed a special sources, streaming sources, using a so-called stream adapter concept. And among stream adapters, we do support sockets, Kafka, Flink, RocketMQ, and many other technologies. So meaning that, for instance, if you want to stream the data from Kafka into the Ignite, you just need to set up this special stream adapter, and this stream adapter will do all the work for you. Well, now we see, so if trying to recap what we learned so far. We deployed Apache Minute on our edge devices. We collected data using Spark streaming APIs. And then Spark streaming transformed and delivered data into the Apache data grid using special streaming capabilities of Apache Ignite. And now, once we have the data in our distributed cluster, we want to work with this data using the rest of the APIs that are available and which are essential for the IoT scenarios. So what can Apache Ignite offer to us? First is an advanced SQL Grid component. So Apache Ignite SQL Grid, so it's a distributed SQL engine which is ANSI 99 compliant. In reality, you can execute all sorts of imaginable functions and operations, including aggregations, joins. You can group your data, you can order your data. whatever you're accustomed to do with conventional relational databases, SQL databases. At the same time, SQL Grid supports, provides and exposes geospatial capabilities, which is useful for the IoT scenarios when you need to track location of, let's say, of your devices like wearables or your vehicles, and you need to deliver this location information to your cluster. And finally, once you deliver this information, you can execute geospatial queries over your cluster. Full text search is also available if it's needed. And finally, it's worth to mention that the platform, as the rest of other components that are part of the product, like data grid, compute grid, streaming, the SQL grid is always kind of consistent and fault tolerant. As for the APIs, how you can access and how you can work with the SQL Grid. SQL Grid, if you take a look at this picture, is just an additional component that is built on top of our cluster, on top of a memory data grid. With the only difference, once you enable your SQL Grid, once you define your SQL schemas, every node in the cluster will store indexes close to the data. And every node stores only a subset of the indexes it is primary or a backup for. Then you can work with you can execute SQL queries using Apache Ignite native APIs, like available for Java, .NET, and C++ libraries, or you can freely connect using JDBC and ODBC drivers, let's say from other technologies and languages and management tools. There are actually no limitations. And finally, to come to to wrap up our discussion around SQL Grid, here is just a general overview of what is actually supported: distributed joins, grouping, sorting of the data. And as for the joins, we do support collocated and non-collocated joins. And all these capabilities eventually allows us to use Apache Ignite for ad hoc SQL queries execution. Next component, compute grid. So this is you might need it if you want to send different computations to your cluster and execute some more advanced logic. And compute grid is just an implementation of MapReduce or fork join framework for Apache Ignite. The most interesting and the most valuable features of the compute grid is zero deployment, which means that you don't need, so if you created, developed, let's say, your computation, you don't need to put jars, libraries with all these computations to all your cluster nodes. Which means that when you decide to execute this computation from your application, a class definition of this computation will be automatically preloaded over the network, let's say on one of the server nodes, and after that the computation will be deserialized and executed. And when this computation, when the class of this computation is no longer needed on your Apache Ignite cluster side, the class will be unloaded automatically for you. And also, as for the compute grid, for sure it supports all the load balancing and provides automatic failover guarantees. For Spark users, so in this webinar, we suggested to use Spark streaming for our data collection and enrichment layer. But at the same time, if you want to keep using Spark APIs, running different computations, transformation, and queries over the data that is stored in Apache Ignite, there is a way to do so. What you can do, you just need to take Apache Ignite and Apache Spark integration, which actually includes implementation of so-called Apache Ignite shared RDD. If you take a look at the picture, Apache Ignite shared RDD is one more API on top of Apache Ignite data grid, which gives you, which is actually a gateway to the data that is stored in Apache Ignite cluster. This shared RDD, they implement and support all the native APIs supported by Spark native RDDs. And the difference between shared RDDs and native RDDs is that a state kind of shared RDD is mutable structure. So, for instance, you can have several Spark workers in your application, and all these Spark workers can reuse the same shared RDD and share the state between each other. This is actually works this way simply because I just want to emphasize, just want to highlight this, because shared RDD is just one more additional API on top of data grid. And the last thing which makes this integration even more attractive is that using these shared RDDs as a gateway to our Apache Ignite cluster, you can execute Apache Ignite SQL queries, SQL queries, that are much faster than native Spark SQL queries. Because, the only reason, probably not the only, but one of the main reasons why Apache Ignite SQL queries are faster than native Spark SQL queries is that Ignite's SQL engine supports indexing, while Spark doesn't support this. And final API that might be using for some advanced IoT solutions when you need to when you need to apply and use different machine learning algorithms. We can offer you to take a look at our machine learning grid, which was released under Apache Ignite or 2.0 around a week ago or so. And presently, what's supported in actually, even before that release, it was feasible to use Apache Ignite for machine learning purposes. What you had to do is just to take data grid and compute grid and create your and implement your machine learning algorithms. And we just decided, just Apache Ignite community, we decided to simplify this process. What we did in Apache Ignite 2.0 release, we implemented so-called distributed core algebra. Now in Apache Ignite 2.0, you can store and perform different calculations using dense and sparse algebra, and you can work with different matrices. Right on top of this, presently the community is already building and developing well-known algorithms, machine learning algorithms, that, for instance, in the next Apache Ignite release, we plan to publish, we plan to roll out algorithms for regressions, k-means clustering, decision trees, and so on and so forth. And also, if there are some of you who are experts in machine learning, we welcome you to join our Apache Ignite community and to take part in the development of this new machine learning framework, which is designed and to be used on top of Apache Ignite computational platform. Okay, guys, that was the theoretical part. Now let's take a look at the quick demo I created so far. The demo is kind of pretty simple, and I'm not going to demonstrate the kind of, I didn't have any device on my table. So I'm not going to send information or measurement samples from real hardware. In this demo, we will use specially created data generator that will send different samples, temperature samples of different meters deployed worldwide. And what we are going to do, so here is this class. Let me increase the font size. Hold on for a second. I need to go to editor, font. Okay, we are going to start Apache Ignite node using this configuration. The configuration is here, and what I did. So I created two caches. The first cache will store sensor-related information. So we suppose that we deployed some sensors in the field that gather different temperature around them and transmit this temperature to our Apache Ignite cluster for further processing. And here's inside of this configuration, we define SQL scheme. So you can define SQL scheme using annotations, so Spring XML configuration, or pretty soon, and also DDL, data definition language. And here is I decided to go for this Spring XML way. And the second cache, in this cache, we will store temperature measurements, temperature samples. And what's interesting about this here is we also define special expiration policy. We are going to store, we are going to evict, we are going to remove entries that are older than 20 seconds old from the cluster. So this is just done for the sake of the sample. And here we are doing the same. We are defining SQL scheme because we want to execute SQL queries on top of our temperature measurements stored in that cache. Okay, let's start a couple of the Apache Ignite nodes. That would be our cluster, our local cluster. The first one and the second one. Let's wait for a couple of seconds. The first node is being run. Okay, it joined, and here is okay. We have two nodes up and running. The next thing, so we have a special code developed for Spark. We use Spark streaming over here. So we are going to create two local Spark workers. And these Spark workers will connect this Spark application, will connect to our cluster using, that before mentioned Apache Ignite and Spark integration. To do this, we need to instantiate special Java Ignite context, passing a reference to Spark context, and the special configurations that will be used to connect to our cluster. So in this application, this scenario, this Spark application will connect to our Apache Ignite cluster just as a client node, as an application. And once this happens, here is how we want to get an access to our caches, to the data stored in our cluster. And we would get this access over the shared RDDs. So here we have a couple of references. Java Ignite RDD, which is our shared RDD. That RDD implements all the API available and supported by Spark RDDs, and also provides something new like special methods for SQL queries execution. Once we connect it from the Spark to our cluster, we want to preload sensors data, some sample data. We are going to fill out sensors cache with with 1,000 of imaginary sensors that are located in different destinations, in different locations. So here is we just randomly calculate latitude and longitude of sensors locations, and we just prepare a special tuple, and here is we push this data into the Apache Ignite using shared RDD save pairs API. And finally, once this happens, once we preload the data, we want to start stream the data from from our devices, from our edge devices to Apache Ignite cluster. And here is we are going to use Spark streaming APIs. We are going to connect to this local host on this port number. We are going to receive data that will include sensor ID, and temperature of the environment around this sensor. We are going to take it, we are going to transform it to another Java pair DD stream. Then we are going to create special tuple pairs. And once these some transformations are completed, finally we are going to push all the transformed and collected data into the Apache Ignite cluster. And at the same time, here is we are going to create a special timer task. This timer task will be scheduled every 4 seconds. And as a part of this timer task, we are going to execute SQL query over the data that is in Apache Ignite cluster using Spark shared RDDs. And we just want to confirm that the data is being streamed, that the number of entries is being changed, and also that our expiration logic works, because as if you recall, we are not going to store all the samples in temperature caches. We are going to evict those that are 20 seconds old. Okay, let's start our Spark streamer. Okay, Spark is ready, Spark context is ready, and now Spark is trying to connect to the cluster. So Spark is connecting as a client node, as a remote application to our cluster. Okay, Spark is up and running, and we instantiated all our RDDs. We preloaded all the data, and this exception says that now Spark streaming context is trying to connect to our devices to get data from there. And as I said, we are going to use special sensor data generator. It would be just server socket that accepts connection and streams sensor ID and some random temperature measured in Fahrenheit to our Spark things. So in your real world scenarios, here is you will be using probably Apache Minute or other operating system that will connect to your Spark nodes and will transmit data there. Okay, now let's start this sensor data generator. Okay, Spark has connected, and now we can see, yeah, the data is being streamed. So now Spark tries to check. We have 47 entries in our temperature cache, and this is a kind of execution result of our query execution. So this is how actually it works. This is kind of one of the templates you might want to use for your own purposes. Okay, good. And final thing, just to finalize our discussion. Here is the resources. So after the webinar, you can go and download the recording as well as the slides. And here is I just share with you some useful links so you can read more about Apache Ignite, Apache Spark streaming capabilities, about Ignite and Spark integration that is used in the demo. And also it makes sense to look at Apache Minute. And finally, the source code of the demo I used so far can be downloaded from here. And so now, if you have any questions, I would be happy to answer on them.
Hi, Dennis. Just wanted to let the audience know that if you have any questions for Dennis, go ahead and enter them in the questions field in the GoToWebinar control panel, and I'll read them to him. There is a question, but I think you've already addressed it, and I'll just read it to you, and if you've already addressed it, I think we'll just, just say I've already addressed it. Can you please highlight some use cases where we can use all of these three? I guess it's Apache Flink, Ignite, and Spark Stream, and what's the basic difference?
Yeah, looks like so. I think that I already addressed this, but actually, if you're talking about, let me go back. If we are talking about data collection layer, it's just you can't, for instance, you can't use Spark, Flink, Kafka, whatever else as a HTTP platform. So here is you have to use some distributed storage, some computational system that can process transactional and analytical workloads. And kind of on Apache software side, probably Apache Ignite is one of the best projects here. But as for the data collection, sometimes it's up to you. So you might want to use Flink, you might want to use Spark, or you even it might be enough to use just Apache Ignite streaming capabilities. So in general, this data collection and enrichment module is optional and it's up to you. But sometimes in some of the scenarios I learned so far, people, for instance, use Kafka as a data collection platform that receives different measurements and samples from the devices. And after that, this data is transferred, let's say, to Apache Ignite or to another system. It doesn't matter, just in case. And here is the same as for Spark. So it's up to you. It's up to your preference, I think.
Okay, next question. For an IoT application, what are the pros and cons of Ignite clusters versus AWS solutions?
So as for the I think that as for the AWS, actually Apache Ignite is a platform that can be deployed everywhere. So basically you can deploy it on AWS as well. So it's up to you. You can deploy it on premise, or you can deploy it on AWS, or let's say on Microsoft Azure environment, and so on and so forth, whatever you like. But if you're going, if you're going to compare to, let's say, to some of the services that are provided by AWS, here is, I think that presently Apache Ignite, it doesn't compete to AWS because actually Apache Ignite is just a full-fledged platform with a variety of capabilities like storage, which can store data in memory as well as on disk, and that provides kind of advanced SQL capabilities, machine learning capabilities, computational capabilities on top of that. And you as a application developer, as an organization, you can get this for free. So you can, everything is available under Apache 2.0 license. So you can get it, you can deploy it whenever you like, and you can use it in the way you like. Hope I answered your question.
Great. Well, that brings us to just about the top of the hour. And Dennis, thank you so much for a great presentation. I just wanted to let you know, the audience, that Dennis will be returning on June 7th, and he will be talking about what's new in Apache Ignite 2.0. That should be a really great talk. And then also, if you're interested, on May 23rd, we're doing a deep dive into the Apache Ignite and GridGain data grid. So we hope to see you on a future webinar. And again, Dennis, thank you for a great show.
Thank you, everyone. Hope to see you soon. Bye-bye.
Bye-bye.